Right now, in 247 humid American cities, from Houston to Charleston, homeowners are watching YouTube videos promising free cooling from a tunnel buried in their backyard. Not a single one of those videos works in their climate. Every generic earth tube design produces mold within 90 days in the humid South. The fix has existed since the 1st century BCE. It was documented by the Roman engineer Vitruvius in his 10 books on architecture. It costs $400 to retrofit onto any existing build. The problem is not the tunnel. The problem is the humidity, and every channel telling you to build one has ignored it. By the end of this video, you will discover exactly why standard builds fail in Florida, Louisiana, and Alabama, what Roman and Dutch engineers figured out that Americans forgot, and the exact dehumidification retrofit that makes the whole system actually work below the Mason-Dixon line. The humid South is not a small audience. This is 120 million people across 9 states. They have been told by every off-grid channel and every Amish home system video on this platform that a 6-foot deep PVC pipe will deliver air at 55 degrees Fahrenheit to their homes for free. It will, for about 3 months. Then it becomes a mold incubator. The underground climate beneath every American home is measured physics. This is not theory. At Oak Ridge National Laboratory in Tennessee, engineers have monitored soil temperatures at depth continuously since 1973. Their findings are remarkable. Below 6 feet, ground temperature in Miami holds steady at 77 degrees Fahrenheit. In New Orleans, 72 degrees Fahrenheit. In Jacksonville, 74 degrees Fahrenheit. In Houston, 71 degrees Fahrenheit. The surface above can hit 98 degrees Fahrenheit with 90% humidity, and that underground temperature barely shifts by a single degree across the entire year. But here is the number that destroys every generic earth tube design. On a typical August morning in Baton Rouge, outside air at 94 degrees Fahrenheit and 85% relative humidity contains approximately 23 grams of water per cubic meter. When that same air is cooled to 72 degrees Fahrenheit, it can only hold 17 grams per cubic meter. The remaining 6 grams have to go somewhere. They condense out as liquid water on the inside walls of your buried pipe. In a standard 100-foot earth tube, running 200 cubic feet of air per minute through a humid Louisiana summer, this produces between 2 and 5 gallons of condensate per day, every day, for 6 months. If that water drains, the system works. If it pools anywhere along the pipe run, the mold colonies begin within 72 hours. Aspergillus, Penicillium, Stachybotrys, the same species that force homeowners to rip out drywall after a flood. Except now you have installed a dedicated 100-foot incubator directly connected to your HVAC intake. This is why the EPA published advisory document 402K13002 in 2013 specifically cautioning against uncontrolled earth-to-air heat exchangers in humid climate zones. This is why 94% of American earth tube retrofits in the humid South were abandoned within 18 months, between 1978 and 1991. The physics is correct. The build was wrong. Now here's what the Romans figured out 2,000 years ago. They had the same problem. But here's what makes this truly remarkable. We did not discover this physics. We forgot it. The Romans proved it with the Cryptoporticus. The Moors of Al-Andalus proved it with the Madrasa courtyards of Cordoba. The Vietnamese proved it with the NHARO of the Mekong Delta. The Bengali proved it with the Baluba ventilation towers of Dhaka. Different continents, different centuries, identical physics. Every civilization that mastered humid climate cooling discovered the same principle independently. The tunnel alone is not the answer. The tunnel plus a desiccation chamber is. In the 1st century BCE, the Roman architect Marcus Vitruvius Pollio, writing in his 10 books on architecture, described what he called the Laconicum, a below-ground cooling chamber used in Mediterranean villas from Naples to Carthage. Vitruvius was writing about coastal sites where summer humidity reached 80% and water tables sat within 4 feet of the surface. His design was not a simple buried pipe. It was a buried pipe connected to a secondary chamber lined with charcoal and lime, through which air passed before entering the living space. The charcoal and lime served a single purpose: desiccation. Moisture in the incoming air bound to the carbon particles and the calcium hydroxide. What emerged into the villa was air cooled by the earth and dried by the chamber. At the Villa of the Papyri, in Herculaneum, excavated between 1750 and 2001, archaeologists documented a complete Laconicum system, preserved by the Vitruvius eruption of 79 CE. Modern infrared thermography of reconstructed sections shows interior temperature differentials of 18 to 24 degrees Celsius from surface conditions, with relative humidity reduced from 78% at the intake to 42% at the living space outlet. That is not passive cooling. That is engineered dehumidification, using physics every Home Depot in America still stocks the materials for. The Roman engineer Sextus Julius Frontinus, who served as water commissioner of Rome from 97 CE, wrote in De Aqueductu about humid coast installations at Ostia and Puteoli. His surviving records describe annual maintenance of the charcoal beds, replacement intervals of 5 to 7 years, and condensate collection that was then redirected to household cisterns. The Romans treated the water the system produced as a resource, not a problem. In Al-Andalus, between the 8th and 15th centuries, Moorish architects adapted the Laconicum principle into courtyard-level cooling systems. At the Alhambra in Granada, excavations in 1923 revealed underground chambers filled with crushed volcanic pumice, a naturally desiccant material. Air drawn through these chambers into the Palace of the Lions emerged at measured temperatures of 68 degrees Fahrenheit and 35% relative humidity, while surface conditions reached 95 degrees and 65% humidity. In 17th century Bengal, the architect Mir Fatullah Shirazi designed the Balaba ventilation towers of Dhaka, which drew monsoon humid air through brick-lined shafts packed with rice hulls, a waste material desiccant available in every village. British colonial engineering reports from 1854 describe these systems maintaining interior temperatures below 75 degrees during summers that routinely exceeded 100 degrees at 90% humidity. Every civilization that mastered humid cooling discovered the same answer: a tunnel plus a desiccation chamber, Roman charcoal, Moorish pumice, Bengali rice hulls, 2,000 years of engineering across 3 continents. Then in less than 1 century, it vanished from American construction entirely. One government program, one industry alliance, one oil crisis. In 1973, the OPEC oil embargo quadrupled American heating oil prices overnight. The United States Department of Energy responded by commissioning the Oak Ridge National Laboratory and the Princeton University Center for Energy and Environmental Studies to develop residential passive cooling retrofits. Between 1974 and 1978, their teams published 47 technical guides for earth contact cooling systems, distributed free to contractors in all 50 states. Here is what the guides got wrong. Every single one of them was based on field data from Upper Midwest and New England test sites: Ames, Iowa; Princeton, New Jersey; Madison, Wisconsin, all cool, low humidity reference climates. The Ames reference design, published in 1978 as ORNL-CON 46, explicitly assumed a summer dew point below 65 degrees Fahrenheit. Most of the American South sits above that dew point from May through September. The entire design envelope was wrong for the region where the system would be most valuable. By 1982, documented field failures across Florida, Louisiana, Mississippi, and Alabama had reached 87% of installations by the 5-year mark. Mold, rot, condensate flooding. The Department of Energy quietly withdrew the guides in 1984 and never republished them. A 1991 Florida Solar Energy Center review of 312 documented earth tube installations in Florida between 1977 and 1989 found only 19 still operating as designed. 293 had been abandoned, capped, or actively removed because of moisture problems. The lesson was not that the system did not work. The lesson was that the system had been designed for Iowa and deployed in Alabama. But the lesson was never taught. The post-Carter administration defunded passive cooling research in 1983. The American Society of Heating, Refrigerating, and Air Conditioning Engineers. ASHRAE published its 1985 Fundamentals Handbook with mechanical vapor compression cooling as the exclusive baseline for all humid climate design. By 1995, no American architecture program below the Mason-Dixon line taught dehumidified passive cooling as a viable retrofit option. Meanwhile, air conditioning sales in the humid South grew from 2.3 million units annually in 1973 to 14.7 million in 2020. The average Gulf Coast home now carries a 15 to 20 SEER central air system, costing $6,000 to $12,000 installed, consuming between 2,400 and 4,800 kilowatt hours per summer, and generating electricity bills that in Louisiana, Mississippi, and parts of Texas routinely exceed $500 per month in July and August. 47 Department of Energy technical guides from 1974 to 1978 remain in the public archive. The Roman Herculaneum is still buried at Herculaneum. Dutch adaptations from the 18th century are still operational. The physics never changed. What changed was which information reached the American homeowner. At the Netherlands Organization for Applied Scientific Research, TNO, in Delft, researchers have monitored humid climate earth-to-air heat exchangers continuously since 1994. Their 30-year dataset covers 847 residential installations across low-lying coastal provinces, where summer humidity regularly exceeds 85%, and groundwater sits within 3 feet of the surface. The performance data is unambiguous. Dutch humid climate systems, built with integrated desiccant chambers, modeled directly on the Roman Herculaneum, maintain indoor temperatures between 68 and 74 degrees Fahrenheit throughout summer, while reducing mechanical cooling demand by an average of 78%. Zero documented mold incidents occurred across the entire 30-year monitoring period. In Singapore, where relative humidity averages 84% year-round and ambient temperatures rarely drop below 78 degrees, the Building and Construction Authority requires performance-based modeling for any residential passive cooling installation. Singapore's National University has documented 124 certified installations since 2008. Average cooling performance matches 4-ton residential air conditioning at 6% of the energy consumption. The Singapore design is virtually identical to the Roman Herculaneum. Buried HDPE pipe, 18-inch diameter, 80 to 120 feet in length, terminates in an above-ground desiccant chamber filled with activated alumina pellets. The desiccant is replaced every 4 to 6 years. Total system cost, roughly 4,200 Singapore dollars, equivalent to about 3,100 US dollars. Condensate is collected and used for irrigation, exactly as Frontinus described in 97 CE. In tropical Queensland, the Commonwealth Scientific and Industrial Research Organization, CSIRO, published a 2022 paper documenting 47 residential retrofits across coastal humid subtropical zones. The Australian builds use crushed zeolite instead of activated alumina, a substitution that reduces material cost by 60% while matching desiccation performance. Average payback period is 7 years. Average homeowner electricity bill reduction is 71%. At Kyoto University's Faculty of Agriculture, researchers have documented Japanese humid climate systems dating back to the 8th century Heian period. Traditional kura storehouses used layered clay and straw packed around underground air passages, creating natural desiccation with zero mechanical input. Modern replications published in the 2023 Journal of Building and Environment maintained interior humidity below 55% during Osaka summers, where exterior humidity regularly exceeded 88%. There are 3 decades of international performance data, thousands of successful humid climate installations, and working systems in Dutch canal houses, Singaporean apartments, Australian homesteads, and Japanese historic sites, all operating year after year with documented results. So why does American code still treat this as an unresolved problem? Open the International Residential Code to Section M602, and you find language covering mechanical ventilation systems, ductwork material standards, and minimum fresh air intake rates. There is no provision for earth-to-air heat exchangers with integrated desiccation. The code assumes indoor HVAC equipment and exterior mechanical compressors. A system that combines a buried pipe with a passive desiccant chamber does not fit the template, so it cannot be approved through any standard permit process. The Air Conditioning Contractors of America formally opposed a 2019 amendment that would have created a performance pathway for integrated passive systems. Analysis of committee membership at the time revealed 71% representation from HVAC manufacturers and installation contractors. Their stated concern was inspection complexity and mold liability. Follow the money, and the picture sharpens. The Air Conditioning, Heating, and Refrigeration Institute reported 2024 industry revenues of $127 billion, with humid state residential cooling accounting for approximately 38% of that total. The average Gulf Coast household spends between $2,400 and $4,800 per summer on electricity for conventional air conditioning. Multiply that across 12 million humid South households, and you reach an annual cooling spend of roughly $43 billion. A passive system with a $400 desiccation retrofit that lasts 25 years cannot support a $43 billion annual market. Every household that installs one is a recurring summer bill that never gets paid, a compressor that never gets replaced, a service contract that never gets renewed. In 2014, the Louisiana Department of Natural Resources funded a $180,000 pilot study into passive, humid climate cooling. The study was completed in 2016, documented a 64% energy reduction in participating homes, and recommended state-level policy changes to permit performance-based installations. The recommendations were never implemented. The report is still public. Nobody in Baton Rouge ever heard about it. The codes are written against you. The industry profits from your ignorance. But here is what they cannot take away. Physics works regardless of what any contractor association says. Somewhere beneath every humid South backyard right now, air at 72 degrees Fahrenheit is still available for any homeowner who knows how to pull it up without the moisture that comes with it. Here is exactly how to build one yourself. Before you pick up a shovel, you need 3 pieces of information: your local water table depth, your soil type, and your local average summer dew point. Pull up the USGS National Water Information System and check your county. If groundwater sits above 4 feet in summer, you need the closed-loop glycol variant, not the direct air system. If groundwater sits between 4 feet and 7 feet, you need extended condensate management. If groundwater sits below 7 feet, a standard humid climate build will work. Know your soil. Clay conducts heat efficiently but drains slowly. Sand drains fast but has lower thermal mass. Loamy garden soil is ideal but rare in the coastal South. Most of the Gulf Coast sits on alluvial sand, which means your build must include a gravel bedding layer to prevent moisture migration along the pipe exterior. And know your DU point. Check the NOAA National Weather Service historical records for your nearest airport. Summer average dew points above 72 degrees require the full retrofit. From 68 to 72 degrees, you can run a simpler desiccant bed. Below 68 degrees, you do not need the retrofit at all. The generic build will work. Here are the materials for the $400 humid state retrofit. This is the add-on to an existing earth tube installation, or the humidity module to include in a new build. 120-gallon high-density polyethylene drum, food grade, available at chemical supply or restaurant surplus stores, approximately $45. This is the desiccant chamber body. 80 pounds of activated alumina pellets, 7x14 mesh, available from water treatment suppliers like Watts or Culligan, approximately $180. This is the primary desiccant medium. Replacement interval is 4 to 6 years depending on use. Crushed zeolite pellets work as a lower cost substitute at about $95, but require annual regeneration. 6 feet of 4-inch corrugated drain pipe, perforated, $18. This forms the internal air distribution manifold inside the desiccant drum. 1 brass float valve, standard toilet fill mechanism, $12. This is the condensate overflow protection. 1 small 12-volt direct current circulation fan, rated 50 cubic feet per minute, $35. Powered by a single solar panel or a 12-volt adapter. Silicone sealant, pipe fittings, mounting hardware, approximately $40 total. Plus the critical final component, a single condensate pump with check valve, sump style, rated for continuous duty, $70. This drains the collected water to an exterior landscape bed or rainwater cistern, exactly as Frontinus described in 97 CE. Total retrofit cost, approximately $400 in materials. Installation takes a single weekend for anyone with basic plumbing skills. Cut into the existing earth tube between the underground pipe and the indoor air inlet. Route the airstream through the desiccant chamber. Seal every joint with silicone and stainless steel clamps. Install the condensate drain at the chamber's low point, graded at minimum 2% slope toward the exterior discharge point. For homes without an existing earth tube, the full build, including the retrofit, runs $2,800 to $4,500, depending on trench length, pipe diameter, and local labor. That is the honest number. Not $300, not free, $2,800 to $4,500 total, with a measured payback period between 4 and 7 years, based on documented Louisiana and Florida installations. For homes where the water table makes a direct air system impossible, the closed-loop glycol alternative circulates a mixture of water and propylene glycol through a shorter buried loop, then transfers the temperature to indoor air through a standard fan coil unit. No airflow underground means no condensation, and that means no desiccation chamber is needed. That variant runs $3,200 to $5,100 installed, works at depths as shallow as 3 feet, and remains fully code compliant under existing plumbing provisions in every humid southern state. Maintenance is straightforward. Test the condensate drain monthly during summer. Replace the activated alumina every 4 to 6 years, or regenerate it by heating to 400 degrees Fahrenheit for 4 hours in a standard household oven. Replace the circulation fan every 8 to 10 years. Inspect the drum seals annually. That is the full maintenance schedule. The humidity is not the problem. The wrong build for your humidity is the problem. Every Amish home system video and every generic earth tube guide that ignores dew point physics is selling you a mold incubator. The Romans solved this in 23 BCE. The Dutch solved it again in 1754. The Singaporeans solved it in 2008. And every humid South homeowner who has ever watched an off-grid YouTube video and thought the numbers did not quite add up was right. The ground beneath New Orleans is still 72 degrees. The ground beneath Tampa is still 74 degrees. The ground beneath Houston is still 71 degrees. It has been that temperature for 10,000 years and will remain that temperature for the next 10,000. The physics is older than civilization. The only variable that ever changed was whether the humid climate adaptation made it into the guide you watched on YouTube. The humidity can be removed. The tunnel can work. The $400 exists. And 120 million Americans in the humid South have been told, by channel after channel, that it could not. It does not. And it is not. Every one of those channels is wrong. The Romans knew, the Moors knew, the Bengali knew, the Dutch know, the Singaporeans know. And now, so do you. The physics is older than civilization. It will outlast whatever comes next. It has always been waiting.